statement. Do not eat any food cooked in an open vessel from a hill station, especially non-veg. Obviously, as a student, I may not have asked the teacher why, but of course, I was curious and kept on thinking about why teacher said, do not eat any food cooked in an open vessel from a hill station. So, assume that I got the courage to ask the teacher at the end of the picnic, or maybe in the first class after the picnic. So she is saying that I'm going to explain you the concept and you need to make out why. Okay, so this was a picture wherein teacher took us to an hill station and she has instructed us not to eat openly cooked or non-veg food. So she took the class. So many students asked the same question. Hence, she said, I'm going to take all the necessary classes for you to understand it. So she talked about the boiling point of a substance, and you can just read that statement. Is the temperature at which the vapor pressure of the liquid equals to the pressure of the surrounding liquid, and the liquid changes into vapor. Very, very good statement. Students have understood, all of us understood, and she also conducted a test at the end, and all of us got very good score. The class 1 is over. Class 2, the teacher talked about what is latent heat of vaporization. It is a physical property of a substance. When a material in liquid state is given energy, it changes its phase from liquid to vapor. The energy stored during this process is called latent heat of vaporization. And teacher also gave us the picture saying that at 0 degree what happens, at 100 degree what happens, what is the input energy given in order to convert from 0 to 100 degree, all that. And all that information was given. Test was conducted after the class 2 also. All of us got good score. Then the teacher talked about altitude and air pressure. Okay. So what is the air column available at the mean sea level? What will be the pressure at the mean sea level? As you go on a high altitude, what will be the pressure? Okay. All these explanations were done. Then she also talked about what is cooking. Okay. Heat absorbed by the food item to make it taste better for the human consumption and easy digesting. Okay. This is the statements which she gave. At the end, teacher asked us why do not eat any food cooked in an open vessel from the hill station, especially non-veg. Assume that if the teachers, you are free to chat on the chat box. I'm not making it mandatory, but if you would like, you can give a chat. Now, the answer. If the students have experienced the concept of boiling point, what is latent heat of vaporization, and what is the difference of air column and the pressure as it goes on higher altitude, probably the student will obviously give the answer. Okay. For this teacher, she did not get an answer from the students, even though taken all the 4 classes. Understand and give an answer, logical answer for this was provided. And quite often, this is our fate. We provide all the required input. At the end, our students may not be able to put them together and give a solution for a problem which is not really connected with that subject, because that's what we are expecting. So anyway, I know all of you are very active faculty members. Yes, I could see some of the very good. Some of the answers, yes, most of them are very close to correct. Yes, correct. And I can explain what the temperature does. What temperature the water boils at different heights. And we can also explain why do we use pressure cooker and why we need an extra weight added on the top. Remember, your pressure cooker, when it is whistling, have a temperature around 120 degree. We are able to boil the water at 120 degree when you provide 1 additional bar of pressure or 1 more atmospheric pressure inside the cooker. So we increase the pressure inside the cooker to 1 atmospheric pressure, that is gauge. You already have a 1 atmospheric pressure as your pressure gauge reads. Then additional 1 more atmospheric pressure. That means 1 bar additional pressure if you provide by putting the weight. That whatever weight you add divided by the cross-sectional area where you are supporting will give you the pressure. So that makes the water to boil at 120 degree. And all the heat which is given, even after 100 degree, is being used for cooking rather than converting the water to water vapor and absorbing it as latent heat of vaporization. So if this is able to be the way in which we look at things, then I'm sure we can make our students to create the new world. Now, we'll take one more case that was from the temperature, and this example is also going to be something close to physics. Why disposable water bottles are corrugated, whereas other bottles are not? Sorry. I'm sure that you have thought about this. You have seen medicine bottles or more than once usable bottles are not corrugated, and single-use plastic bottles, normally it is corrugated. Do you like to give me an answer on this? Why? You can chat. I'm able to see some of the good answers on the chat box. Very good. Thank you, professors, being so active and participating. So in your opinion, why single-use plastic bottles are kept corrugated, whereas the medicine bottles or bottles which we use repeatedly for water, water bottles, etc., are plain? What could be the reason? Keep guessing the answer and typing it down. Remember, nothing is going to be lost. Nobody is going to grade us on this. But once we start thinking about it, we can also make our students to think and react in the class, even if it is an online class. Okay, crushing may be easy. Very good. Krishnaji said crushing may be easy. Others can also just type in some of these inputs so that we just get to know how things are. Okay, the glue allows the bottle to be crushed in a way which renders useless after use. Okay, Ashok Kumar sir has given that answer. It is easy to destroy. It can be easy to recycle. Good. Okay, so I want some physics teachers to think about this. Assume that I have given you 10 A4 sheets and asked you to make a bridge using that. Asked in the class, whoever keeps maximum number of books on the bridge which they make using and get the prize. Obviously, we are looking at moment of inertia. If I can move the area from the center of the axis, like in an I section, I should be able to get much better bending strength. And that's what is being employed in many of these corrugated buildings or building with curves, etc. So this we teach in physics quite often, and we have communicated this so well, the bending stress formula, all that. And what is moment of inertia? Probably we have been doing it from 11th standard onwards. But the application of that, if I want to make my bottle so thin, I can't put it on a same plane. I will displace the area from the plane of acting force acting perpendicular to that plane, so that I get the area away from the axis. That makes the moment of inertia higher, because my bending stress is sigma, which is my divided by ix. That is the moment of inertia. So look at this. We use it for many applications. You have seen this kind of twist given to machine elements, and it gives you much better what you get from a simple plane thing. Okay, request all of you to mute your mic. So let us just look at probably one more case. I'll just take a case of the smoke which flows downward. I'm sure you are able to guess what it is. If you ask questions of this kind in the class, probably they'll start thinking, normally smoke has to move upward, moving downward. And in every movie we see, especially now Ramayana, Mahabharata are relayed. So you can see this kind of things in every movie. So if we are able to kindle the interest and give them an experience of the basic concept, probably we are going to be really much more effective. Let us just look at one more from. Next time when you get a chance to look at the tube light, look at it and it will be written 6,500 K written on the tube light. What is the temperature in Kelvin on a light to do with, what light has to do with the temperature? I'm sure you are aware of this. We explain the light in terms of temperature. Soft white light is 2,700 Kelvin and cool light is 4,100 Kelvin, and daylight is 5,000 to 6,000 Kelvin, 6,500 Kelvin. So if the tube light is given 6,500 Kelvin as a marking, it means it's a daylight what it is producing. The content is similar to a daylight content. Okay, so this is to just say how do we look at things in a different way. Now, assume that in this pandemic situation, you are going to your first year class. Those who have come with 11th and 12th and hard work of either CET or some entrance examination come to your class. Now, you're going to ask them, can you help these people to carry the load better or with less effort so that whatever you study, you can apply to a real life problem statement? Okay, assume that some of them are able to give you an answer. And what we'll do is we'll look at the answer and see what is the basic physics which is being used here. Look at the first picture, first, second, and third, and see whether you are able to make out what. I'll just take the first picture. You're able to make out what is really is the physics applied in order to reduce the pain that the. Feel free to type in the chat box. So how did we reduce the pain or burden of carrying the load by providing this approach? What is the basic physics? I'm looking for your chat, load distribution on shoulder, good. Look at this. If load distribution, many have center of gravity, okay. Okay, good. Keep typing in. See, this equation we have been teaching people quite often, the students quite often. But this is one of the applications. That the same applied to a wider area so that pressure or the pain which comes because of the load is reduced. Okay, so force by area, pressure, and you can even make the students experience it in the class. Ask them to take the pencil, ask them to just press on the sharp side and the other side, and with the same force, if they press where the pain is maximum, you can ask them to feel it. The second one, look at the second one. Here, I've also made it a little more complex to make it dynamic, but it is all to do with the center of gravity. So we are able to move down to close to the CG. So from CG, when the load is far away, even a small change in position creates a moment. So moment is something which we teach in the class. So this moment need to be reduced so that it can come together. And similarly, you can also look at every one of these cases. From here, now after explaining this, you would like to ask them, that's all right. You have done some of this basic physics understanding on that. Can you help carrying the water on the head? So this is water. I need a bottle or a vessel, and I need to go to the well and get it, and assume that I'm far away from the well and I need to carry it. So this is a condition. We'll just look at the solution. So this is a solution which was proposed by some NGOs. Look at, it's a vessel and an end cover on either side, and you can see an pushing element so that it can be acting as a trolley. And it is being supplied in India quite well. It's an UK NGO which made this. Now you can extend it further, because if you want to really excite them, you want this to be analyzed from the physics point of view, the way in which you carry the load. look at what complexity we can add even for a simple structure like this, and we can increase the complexity and do analysis and make sure that they understand what their study is required when they want to make analysis as close as possible to the physical system, and they can do a lot of optimization and related stuff using that. With this basic thing, let us just get into why we are here and why we need to look at experiential learning. I'm sure that gurus also have evolved now. It is not only we saw the kids moving the road with support because they are always glued to the screen. Now gurus have changed. I hope you are able to guess what will be the next picture. So we have been doing dhyana like this nowadays. And our young friends have been always looking at the loves and likes they get on their social media posts. Now the question is, can we use the same media online for online education and to provide experiential learning? So that's a task in front of us. We are looking for help. Where do we get a help if we want to do experiential learning, provide experiential learning online? So when we think about experiential learning, this is what we come to our mind. We have to do it with hand. If you are doing it with hand, be ready for this. Otherwise, let us get into the dumb box and let us use the computer to get the experiential learning. Assume that I will ask you to teach cycling using a textbook. We will give her 3 textbooks and ask her to study everything. And afterwards, after 4 years, I'll give her a cycle and say that you have studied everything, you got 100 out of 100, please ride the cycle. In fact, we are making the same thing in engineering. So we keep them on the shore and we teach everything like this. And we expect after 4 years, they will do engineering. In fact, we are making them to read engineering and we are expecting them to do engineering. Rather than that, let us do engineering at the beginning itself rather than reading engineering. So from telling concept to evolve, to make us evolve to telling concept to experiencing the concept. I'm sure you are dreaming to do this now because long since we have gone to a class and had seen the bright, smart faces of our students, now we are all online. And with whatever facility we have been trying to do our job best. And here we need support. So when we are looking at support, let us see how we can look at support and where we can create it and how do we use it in the class. I'll take one quick example for a general thing. Assume that you are looking at the sewing machine and you want this to be looked at from either science perspective or an engineering perspective. Just look at this diagram, wherein some input motion is given. I'm getting that input motion getting converted to the required motion and get the final outcome. So swing machine, I have an input displacement, which is a pedal swing. Then the output motions are needle moving up and down, cloth moving forward after each stitch. The modification required is the pedal swings to rotation first, then we need to convert that into reciprocation of the needle, then again for moving the cloth forward. All this is achieved by some kind of mechanisms. So we are looking at an input for a system and make a system get the desired output. This is called the systems approach. Or either the output may be known to us and we have no control over the input. If so, then make the system so that it can take any input and get the required output. Or assume that you have control over the input, then give the desired input so that you get the desired output. So this is what we do in physics as well as other engineering field to make our transfer functions for any given systems. Okay, from there, so I hope I have made it clear what is that we are looking at. We are trying to make engineering education and science education more experiential, even if it has to be done online. So all of us need to start dreaming. So let us dream what do we need to dream? We need to dream about teaching and learning. We have three stakeholders: administrators, teachers, and the students. Now, you go and ask your head of the department or dean or director or a principal saying that you need this facility to be created for online classes. I need to make a simulation, so I need a MATLAB license, or I need one workstation to make this. I'm sure that they are going to say point blank no now. And what about the teachers? We have been pushing our teachers to extreme, and we have been making them comfortable with an uncomfortable terrain, that is online classes. And they have been doing a lot of reading and understanding on what they have to do, which they were not so comfortable in doing it in the class. So we can't ask them to do more. And what about our smart and bright students? They're always online. Now, they want to know, how do I make this online presence much more effective for their own learning and concept clarity? So let us look at what are we dreaming about in teaching and learning. So we are dreaming about a learning management system where everything is available in one place. I don't need to search all around. And a lab where I can experience. But that should be in my place. Wherever I am locked down, there I should get this. It should be in my pace. That means whatever the experiment which I would like to do, it should be such a way that if I want to do it faster, I should be allowed to do. If I want to do 3-4 times, I should be able to do it. Similarly, at my own time, whatever time I am interested, assume that early morning, 4 o'clock, I want to do an experiment to get an experience. Don't ask me what. So I want to get an experiential learning at my time. So that should be possible. So remember, this is a dream, and we are trying to see, can we realize this dream? And we want the lab to be a home lab or carry with me lab. And it should not have a lock and key and no holidays. Whatever said and done, all of us have our own syllabus to be followed. So the lab needs to be for my syllabus. And I should be able to help my students to get the dream job. And if they are already out and on an old job, they should be able to change the job, or they may be able to switch between IT to core to management, or any other new area like AI and ML and things of that kind. So when we look at these specifications, it's something dreamable. Without asking any additional money from the administrator, without asking our teachers to do much more learning and adapting to the new things, or providing our students the best possible correct solutions which they can experience is the need of the hour. So towards that, Ministry of Education have been doing a lot of things much before this pandemic. In fact, this was started somewhere in 2010. It's already a 10-year-old project. It's an initiative from Ministry of Education. Earlier it was known as Ministry of Human Resources and Development under National Mission on Education through ICT. There are 7 old IITs, and from Karnataka we have NITK Surathkal, that's how we are interacting now, and IIIT Hyderabad, Amrita University, and COEP Pune along with Dayalbagh University. All the institutions together, 12 institutions together, created more than 100 labs so that students and teachers can get experiential learning either on a physical classroom where when they're teaching the subject, they can make use of it, or now in this new normal online classes, we should be able to use this same material for providing experiential learning and making the clarity concept on the clarity on concept while delivering the lecture. So let us just see what it is. Assume that you want to just look at PV by T is a constant, either how the pressure, volume, and temperature is going to affect on a predefined volume of gas. Then I have a typical equation to work with. PV by T is a constant. So P1, V1, and P1 and P2, V2 and T2. I can play with that. So such things where the equations are available, or some way you can find equations, modeling and simulation-based labs can be created. Or in case of material testing, you want to find out the strength of different materials by breaking it. Then break n number of materials and collect the data, keep it in a repository, and when the student come to do an experiment, say brass of this dimension, I'm going to break, do the experiment. When he asks for the result, give the actual result which you already saved. The remote triggered lab is a lab wherein you should be able to trigger an actual experiment and see whether what result it comes. So these are the three types of virtual labs. And all that you should be able to do with your comfort at your computing device, which is connected to the internet. It could be a tablet or a mobile phone or a computer. And at the NITK Surathkal, we have done it at Center for System Design, which is a transdisciplinary research center. Okay, I will do one thing. I'll just straight away go to demonstration so that we'll just see. This is the virtual lab site where you should be able to see what are the broad areas of the lab and which are the universities. For at each position, each rotation or each angle of the crank, where is a position. So I can keep changing this parameter and see what happens to the result. Now, the position is changing with respect to time. That means it is attaining velocity. Once I have velocity, the advantage is, so when you have velocity on a mass, so you get kinetic energy. So when you have kinetic energy, you can make that part to do work. So here I can look at how much kinetic energy I'm able to get at different positions, different configurations, and assume that you have a question paper wherein it says R is equal to 40, L is equal to some other value. You can even get the solution by just typing in the data here and find out what are the velocities. If I just pose it at 1, I should be able to get the velocities corresponding to this. So in order to explain this in a classroom, it's very difficult, especially for those who are taking kinematics, statics, or dynamics. This is something which they come across in physics, and it's very difficult to explain. So from there, when the velocity is changing with respect to time, we do get acceleration. So a mass experiencing acceleration as per Newton's second law is going to be the inertia force which is equal to mass into acceleration. Now I am interested to find out if the piston has to be stopped or if piston have to be given the motion or the required way, how much force I need to provide. That is nothing but m into a, mass into acceleration. Once I know the piston mass and what acceleration I should provide, I can torque I need to give, etc. So that gives me what kind of a motor to be used, at what speed it should run, all that. And that can be provided by, can be checked by changing the parameter. You can even change all this parameter and see what happens at each position. You can stop it and get the feel. If you want to check out one old question paper, probably you can type in the data. I can use it as a tool for getting the solutions. Or if you're asked to quickly make a question, you don't need to struggle in putting the value, doing all the calculations. You just randomly put the value here, get an appropriate screenshot and get the data, and that will become your question itself. So that way, we should be able to support every one of you on your domain. Of course, I'm just demonstrating few of this, whereas my team members will demonstrate for each one of your area. They have taken few sample examples. So they will cover that first. After covering what they have done, they have prepared and come for, you should be able to ask them for more. And we would suggest you not to interrupt in between because we have requested them to come and talk to you, and that is on our request. They have the resource people have come to tell you. So listen to them first. Then after they complete, you can ask them what else can be shown, or if you have a specific request. So now this is a mechanism which mechanical engineers quite often use, which can be used to generate a simple harmonic motion, which we call it as an Scotch-Yoke mechanism. Here you can see the motion, velocity, and acceleration all being plotted. And you can keep changing the parameter and see how it moves. Or those who are from, want to look at the motion, which is like this, elliptical cam, or maybe many such experiments can be tried out in your free time to see how each of these can be used in your online classes. I'm just trying to show you one more experiment. I'll just open this and keep things, then I will show you the experiments. This is a remote triggered experiment. We should be able to get the live stream. It takes some time. I'll just keep opening the other experiments so that by the time we come there, we should be able to get all the videos ready. Yeah, it's ready. You can just look at it. This is a simple pendulum. I'm sure that all the physics teachers have been teaching simple pendulum for long. Now, I'm going to just trigger this pendulum. I'll trigger this and let us see what happens. This is an actual experiment situated at NITK Surathkal. So the pendulum is triggered. Now I have a chance to get the data, and I can even control how things can be shown to the students. Okay, by the time it gives me data, I'll just go to the next experiment. I'll trigger this experiment. Okay, this is an experiment on a beam. I'm sure all of you are quite familiar with this graph, the logarithmic decrement. When you impart an energy to the system, it changes. Take the case of a simple pendulum. It changes from kinetic energy to potential energy and keep changing that energy and give you the motion. Okay, and this can be explained. Similarly, many other experiments can be done online. So I'll just take one more example wherein those who are looking at the input, this is an input where I'm giving an sweep sign input to a system and trying to find out what response it gives for a sweep sign input. These are small experiments wherein you won't be able to really make out how much of vibration which happens here. So this way, you should be able to try many of these experiments online. Okay, this is taking a bit of a time. I'll just get back to my presentation. Yeah, now what I would like you to look at is this data has come. I'm able to see the